Hey there, in this video we're going to look at the method we use to divide complex numbers. So here's an example of a complex number division problem. We've got 2i in our numerator and the complex number -1 plus 3i in the denominator. This looks sort of like a polynomial, but we want to be careful and remember that we cannot treat I remember, meant to write remember. Remember, I is not a variable. I is a constant number that always has the same value. I is equal to the square root of -1. And when we remember that I is really just a type of square root, that gives us a clue as to how we could treat this fraction. When we have square roots in fractions, we need to rationalize the denominator, meaning we want to get rid of any square roots in the denominator, which in this case means we want to get rid of any i's that are in our denominator. And we've learned before how we can get rid of square roots that are in the denominator of a fraction. What we can do is multiply the numerator and denominator times the conjugate. So we need to be careful that we cannot just cancel out these square roots, because that is not the method we use to get rid of square roots in fractions. We need to instead multiply the top and bottom of our fraction by something that will cause the square roots in the bottom to cancel out. So let's continue this example and let's see what our method is going to be. There's a tool we can use that will cause the imaginary part of a complex number to disappear, and that tool is multiplying times the complex conjugate. Remember that the conjugate of an imaginary number, a plus bi, is a minus bi. So we keep the real portion the same, but reverse the sign of the imaginary portion. If we want to get this imaginary in the denominator to cancel out, we can multiply by the conjugate, which would be -1 minus 3i. But if we multiply something into the denominator of a fraction, we also need to multiply that same expression into the numerator so that we're not changing the overall value of our fraction. So that is the method that we'll use to rewrite this complex fraction so that we get rid of any imaginary parts that are in our denominator. When we multiply times the complex conjugate, we know that the imaginary parts are going to cancel out, so we just need to multiply the first two terms together, the real parts of this number. -1 times -1 would give us +1, and we can also multiply together the imaginary portions. 3i times -3i is -9i squared, and remember that I squared is equal to -1. So we should always rewrite I squared as -1 when we're simplifying an expression. That means that -9i squared is -9 times -1, which is +9. So the denominator of this fraction becomes 1 plus 9. And if you're familiar with multiplying more than one term times more than one term, you might be thinking, well, but didn't we also forget to distribute and multiply these middle two terms and these outside two terms? But we don't need to go through that extra step when we're dealing with conjugates, because these terms having opposite signs means that the terms from that multiplication would just cancel out. So that's a shortcut we can use when we're multiplying by conjugates, is just multiply the real portions together and the imaginary portions together and simplify I squared into negative 1. In the numerator, though, we will need to distribute and multiply everything out because we're not just multiplying two conjugates together. So we have 2i times negative 1 gives us negative 2i. 2i times negative 3i gives us negative 6i squared. I times I is I squared. And again, we want to use the fact that I squared is equal to negative 1. So we could rewrite this all as negative 2i minus 6 times negative 1 all over 10. Now when we simplify this, let's first just multiply these two numbers together. So that gives us negative 2i plus 6 over 10. And now that we're dealing with a fraction, we should check and see if it's possible to simplify by dividing by common factors in the numerator and denominator. Every term in this fraction is divisible by 2. So let's divide the numerator and denominator by 2, and we'll just get negative 1i plus 3 over 5. Whenever we are dividing complex numbers, what we want in our final answer is that there are no more imaginary terms in our denominator, so that we don't have any more square roots in the denominator. But it's okay to still have real and imaginary parts in our numerator. And if we want to leave our final answer like this, I think that's all right, but you just want to get used to the convention of writing complex numbers that typically we want to write the real portion plus the imaginary portion in that order. So instead of writing negative I plus 3, it'd probably be more common to write it as 3 minus I. So now let's work through some more examples and put this method to use. In each problem, what we want to do is multiply times the conjugate of the denominator, which means that we'll keep the same real term from the denominator, but switch the sign of the imaginary term. And remember that if we multiply times something in the denominator, we need to multiply times the same thing in the numerator so that our fraction stays balanced. In our denominator, we have 3 times 3 gives us 9, and negative 3i times 3i is negative 9i squared, and we're always going to have I squared in the denominator after we complete this step with the conjugate, but we should always turn I squared back into negative 1 and then multiply times whatever number we need to multiply by. So negative 9 times negative 1 is equal to positive 9. So our denominator is 9 plus 9, which is 18. In the numerator, we need to distribute 5 times 3 gives us 15. And 5 times 3i gives us plus 15i. So we have 15 plus 15i all over 18. And let me rewrite that down here so we've got a little bit more room. Whenever we're dealing with fractions, we should always check to see if it's possible to simplify by dividing by a common factor in the numerator and denominator. Well, all of the terms in this fraction share a common factor of 3, so if we divide everything by 3, we'll get 5 plus 5i over 6. And our final answer should be a fraction that has no more imaginary terms in the denominator, because an imaginary number is really a type of root. It's the square root of negative 1, and we don't want to leave square roots in the denominator. In this next example, we'll multiply times 2 minus 6i in the numerator and denominator. In the denominator, 2 times 2 is 4, and 6 times negative 6i is negative 36i squared, but of course I squared is equal to negative 1, and negative 36 times negative 1 is positive 36. So our denominator is 4 plus 36, or 40. In the numerator, 3i times 2 is equal to 6i, and 3i times negative 6i is negative 18i squared. I squared should always be simplified into negative 1, and negative 18 times negative 1 is positive 18. So we have positive 18 plus 6i all over 40. And we can also simplify this fraction. Let's see, what is the biggest common factor? It looks like it's going to be 2. We can divide 18, 6, and 40 all by 2, and that will give us 9 plus 3i over 20. Here's 2 more examples for us to try out. We'll start by multiplying by the complex conjugate in the numerator and denominator. In our denominator, negative 9 times negative 9 is positive 81. Remember that a negative times a negative equals a positive. Negative I times I is negative I squared, but since I squared is equal to negative 1, this is really negative times negative 1, which is positive 1. So our denominator here is 81 plus 1, which is 82. In the numerator, 2 times negative 9 gives us negative 18. And 2 times I is 2i. So we've got negative 18 plus 2i all over 82. And all of these terms are even, so we can divide. Sorry about that. Still figuring out a little bit how to use this touch screen. We can figure out how to divide. I'm sorry, I am figuring out the touch screen. I think you don't need to figure out how to divide. That part you've got down. So let's divide by 2 in the numerator and denominator, and we'll get negative 9 plus I all over 41. In this final example that we'll look at, notice that we have 2 terms in our numerator. So that means that when we multiply times the conjugate into the numerator, we'll need to distribute and multiply all of these terms together. In our denominator, though, we can still use our shortcut for multiplying by the conjugate. Just multiply the real portions and the imaginary portions. So 6 times 6 is 36. 3i times negative 3i is negative 9i squared. I squared is the same as negative 1, so this is negative 9 times negative 1, which is positive 9. So our denominator is 36 plus 9, which is 45. In the numerator, we've got negative 3 times 6, giving us negative 18. Negative 3 times negative 3i is positive 9i. Negative times negative is positive. I times 6 is 6i. And I times negative 3i is negative 3i squared. And there's our friend I squared again, which is equal to negative 1. So negative 3i squared is the same as positive 3. Now we can combine together some like terms. Negative 18 and positive 3 gives us negative 15. 9i plus 6i is 15i all over 45. And we can simplify this as well. 45 is the same as 15 times 3. So we can divide everything in the numerator by 15 and everything in the denominator by 15. We get -1 plus I all over 3.